All right, so check your answers with mine. Ask me any questions you want. You will notice I left the concavity for the square root and the reciprocal blank because I want us to do those together. I left it blank. Yep, I'm gonna do it with you. Sorry, Kelly's covering it. Yep, I'm gonna do that one. I do want to talk briefly. Can I talk about the quiz? Is that okay, online and in-person people? Yes? All right, y'all, when I know you better, the next time we take a quiz, I'm going to throw something at you if you miss another domain question. That is math 1. It gave you a graph to look at. Some of y'all were putting the range. What does domain stand for? The x's, so I don't know why some of y'all were putting the y's. I don't know. It literally gave you the graph and it started over here at -6 and went to the right. So what's the domain? -6 to infinity. Why 0? If it starts at -6 and goes to the right, it is -6 to infinity. Now, also, for those of you that just said, I didn't know how to do it, I'm gonna beat you. Because yes, you did. We've been doing this the past like 3 days. A square root cannot be what? No, it can be 0. Square root of 0 is 0. It can't be negative, which means it has to be greater than or equal to what? So all y'all had to do yesterday was do x plus 6 greater than or equal to 0. So what does x have to be greater than or equal to? Oh, bless. Not 0. Solve. What is it? -6. Thank you. Oh, I don't blame myself for that, though. I blame whoever y'all had for math 1. Yikes. Not at her. I love her, but my math 1 kids will be able to tell me domain and range after this year. You got to make sure you know how to do that. Especially if one of them gave you the graph. I can't remember if it was this one, but one of them like showed you the graph. So all you do is look at the graph, read it left to right. It's the smallest one on the left to the biggest one on the right. It's x's. Are y'all okay with the stuff for a square root function? Do y'all see my end behavior? Yes, no. Okay, there's only one end. The initial point is 0. This doesn't keep going, right? Because I can't have a negative. So it only goes to the right. So as x approaches positive infinity, do y'all agree the y is getting bigger? It's going up. So that's your only end behavior because it only has one end. Are we okay with that? All right, people at home, y'all can't see me anymore, can you? Can you see me now?
No, I can still see.
Okay, cool. All right, let's talk about concavity. Concave up. I'm going to get really corny. Mr. Polk was so proud of me because I made this up on my own. Concave up kind of sounds like cup, correct? Yes. Go with me. I'm being corny, but go with me. If I were trying to pour something into the graph, it can cup it and hold it in there, even if it's just a little bit. That is concave up. Okay? If the graph kind of looks like, even if it's sideways like this, if I try to put some water or rocks or whatever in this cup, is it going to hold anything? No, so that would be concave. Does that make sense? Does it help you kind of visualize it? Look at this square root graph. If you tried to pour anything into that cup, into that curve, would it hold it? So it's what? Good. I told you I get really corny in here. Are y'all good with the square root function?
Yeah.
Okay. You don't need to know necessarily all of these features right now, but we're going to get into them more next unit. So that's why I wanted to introduce it now, okay? This is not on your test. There is some domain stuff on your test. Please don't miss it again. But other than that, if you are struggling with domain or something like that, you need to get your booty in an office hour Zoom. We can work on it. All right, the absolute value function. Are y'all okay with my work? Let's talk about the quiz again. Yesterday on the quiz, I think it was this. I could be wrong, something like that. You see my pink? Yeah? Okay, look at the graph of an absolute value, and y'all knew the graph looks like this. It's a V that goes to the left and right forever, right? Yes? Okay, so you could have written negative infinity to infinity. I also had some of you, because you were eavesdropping on me and Ross's conversation before the quiz, psyched yourselves out and you put this with brackets. That is acceptable because it can equal 3. So I went back, and if you put that, I gave you credit. All right, but an absolute value function goes to the left and right for forever. So what me and Ross were talking about, Mary asked if the domain was multiple choice. I said no. And then she said, if it was multiple choice, would you put all real numbers as an answer choice? And I said maybe, but it would never be that because that's too easy for multiple choice. All right. Okay. Are we okay with the rest of the absolute value function? So even though this isn't curved, it makes a V. So if you try to pour something in it, it would stay, right? So that is concave up. As X goes to the left, the Y is going up. As X goes to the right, the Y is still going up. Did you guys see this notation in Math 3?
I don't even know what that is.
They're just both positive infinities. So this one is for when X approaches the left. This one is when for X approaches the right. You might see it written like that. That just means both ends are going up. Okay? I just wanted to show it to you in case you see it like that. No one has questions because some of y'all's were incorrect. We're okay? All right, let's look at our reciprocal function. Most of y'all's domains and ranges were good. So we've got 2 asymptotes here. We've got one on the y-axis and one on the x-axis. Is everybody okay with that? So I can't put 0 into x because that would be called what? Oh, right, but why? What's that called? Why can't we divide by 0? Help them out, people at home. They're just staring at me like I'm speaking Spanish. I can speak Spanish if you would like.
Is that an asymptote?
Yes, but I'm asking why. Why is there an asymptote on the x-axis? Why can x not be 0?
Because the denominator can't be 0?
Right, the denominator can't be 0 because that's called what? There's a math word.
Undefined.
Thank you. Oh, good. Okay, good. There is hope in the world. Undefined. You learned that in like 7th grade. Okay, well, remember it now. That is undefined. All right. So there's an asymptote here. Now, there's also an asymptote on the y-axis because is this ever going to equal 0? No, no matter what number I put in down here, it's not going to be 0 because 1 divided by something, if it's not like 0, cannot be 0. So there's also an asymptote here. So your domain goes from negative infinity and then it's going to stop at 0 because there's an asymptote. Then it'll pick up at 0 and keep going to the right to infinity. Same thing with the range. It starts at the bottom, goes up till it hits 0. Then there's an asymptote, so you got a break, and then 0 to infinity. Does that help? Yeah. So domain is left to right, correct? So if you start on the left, this keeps going, but then it stops at 0. So then, do you see how it picks back up here? So the x is close to 0 up here, and then it goes to infinity. Left to right is domain. range is your y, so you start at the bottom. This arrow goes down forever, so it comes all the way up here to this asymptote, which is 0. And then it picks back up right here when it's really close to 0 and goes all the way up to infinity. We okay? All right, some of us are missing this. We need to make sure we're okay with this. When you do increasing and decreasing, you read a graph from left to right because we're talking about when it increases or when it decreases. So I'm talking about the x's, right? Yes? Y'all are boring me. Yes?
Yeah.
This stuff is very boring for me too. No offense, but like I know how to do it. So I'm just like, all right, let's go. So if I read this from left to right, if I start on the left, what is this first blue curve doing? Is it increasing or decreasing? Good, it's going down, very good. So it's like this, and it's going down. Okay, now find your other part, keep going left to right. It's up here. What is it doing up here? No. Go left to right, left to right. What is it doing? Left to right, going, which means it's decreasing. The whole function decreases. You read it from left to right. Just because it's pointing up, if you go from the left to the right, that's going down like a slide. So it is decreasing the entire time. It just stops at 0 because at 0 there's an asymptote. Got it. Oh, you better get over that. Pre-cal is all graphs once we hit unit 2, next unit. They're really not that bad. I enjoy them, but I'm a visual learner. No intercepts because there's asymptotes, right? Doesn't touch the x or the y. End behavior. So when x goes to the left, the y is approaching 0. Does everybody see this? As x goes to the left, this line approaches and approaches 0. As x goes to the right, this line is still approaching 0. If there's an asymptote, most of the time, your line is going to approach it, okay? All right, and this is the tricky one. If we look at this cup, this one right here, if I tried to pour any water in it, could it stay? Even just a little bit, could it stay? A little bit would stay. So this part is concave up. So it is concave up. Notice how it's on the right side. Does everybody see that? Yes? So it's concave up from 0 to infinity. What about the bottom piece? Would that be able to hold any water, rocks, anything? No, so that would be concave down from what to what? It goes to 0. It's on the left side, so what to 0? There we go. Good job, children. How we feel, okay? Yes? So, second time I'm saying this. There is no concave up in behavior intervals of increase, decrease questions on your test. Just some domain again, okay? Does that sound fair? I thought about putting it all up there, but I went and took it off last night. I'm hoping y'all's test grades are better than them quizzes. We good? Questions on this? Going once, going twice. Ask me any questions. People at home, we're good?
Yes.
All right, beautiful people. Transformations homework, and then we're moving on. Sound good? Hang with me. So I think I need to do 1 and 2 and 5 and 6. Are y'all good if I just write the answers for 3 and 4 real quick and you check them? Okay. For 3, let's see, it's absolute value. So y equals absolute value, x should be inside. Then it says left 5, so plus 5, up 3, and reflected over x. So watch what I'm doing. That would be a vertical reflection, right? Okay, so that goes on the outside and compressed by a third, so negative 1/3. Is that good?
Is it fine if we put f of x instead of y?
Absolutely, it is fine if you put f of x. They mean the same thing. Very good. I'll do it for this one. Probably should have done it for that one, but that's okay because it said f of x. All right, so this one is a quadratic. So x something squared. Right 12 means minus 12. Down 5 minus 5. Stretch by 4. Good. We're okay with that. Okay, good. I get sad when we're not okay with that part. All right, so let's go up to, what do y'all want to do first? 1 and 2 or 5 and 6? 1 and 2? Okay, so for 1 and 2, I'm going to zoom this in really close so y'all can see what I'm doing. Some of y'all caught 70s or 85s on your homework because you did not read directions. What does it say to do? What's the parent function? Thank you, Chris. There's your parent function. What did it ask you for next? All of the transformations. So I wanted you to do that next because those transformations should help us graph it, okay? So tell me some transformations of number 1. Oh, good. Down 5. Love it. Left 2. Love it. Vertical compress. I heard by 1/2. That's good. And very good, Ross. Vertical reflection because there's a negative. A lot of y'all, when you got down to 5 and 6, didn't even check for reflections, stretches, or compressions. So yes, it's usually pretty easy to see the shifts, but we got to check for everything, okay? Questions on the transformations part? Yes, no? Okay, the graphing part. Is everybody okay if I show you how you learned how to graph it in Math 2? Yes? If you don't like this way, don't freak out on me. I will show you a second way. Sound good? I try to show y'all more than one way when there is more than one way, okay? So in Math 2, you learned to graph the initial point first. The initial point is the middle point where the graph starts. It's supposed to be at 0, 0, correct? But if we moved this left 2 down 5, where's the initial point going to be? Good. Why did y'all not answer that? I just said if it's not at 0, 0, if we move it left 2 down 5, where's the initial point? And you all stared at me except for Brody. Are y'all okay today? That's okay. I can't teach y'all horizontal stretches and compressions today, though, if you're not going to answer me, because I need to know if you don't get it. Are we good? We're going to participate. Okay, otherwise I feel like I'm up here working for no reason. Online people, y'all can chime in if you want because they being too quiet. So the initial point should be at -2, -5. You should have gone and put a point at -2, -5. So right here. That's your initial point. Now from there, your Math 2 teacher should have taught you that you use the A value to find the next point. Okay, so look at x cubed. We know x cubed normally is shaped like an S, right? Well, that's when it's positive. Which way should it be going up on? Which side should it be going up on if it's reflected? The left, good. So the up part should be on the left, which means the right side is going to be the down part. So let's talk about x cubed really quick because y'all are going to stare at me if I just do this. Because not all the Math 2 teachers taught you why. I like to teach why because I like you to know what we're doing. How far away are each of these from each other? 1. Did we have any kind of horizontal stretch or compression? No, because I haven't taught you that yet, right? So this is not a trick question. The X's are 1 away. So look what I'm gonna do. I'm gonna go to my initial point and go 1 away horizontally. Why am I doing that? What did I just show you? The table. Aren't the X's 1 away for a cubic function? So I'm gonna go on my graph and go 1 away. And I didn't mean to put a point there. Don't put a point there. Now, what's your A value? -1/2. So look, when you go over 1, this next point should go down 1/2. So over 1, down 1/2. There's my next point. On the other side, we are going left 1, which means it's automatically already negative or positive? Negative. So it's already negative. So now I'm going to go up 1/2. And these are your 3 points. That green is hard to see. Let's do this. I need you to be real with me for a second. How many of you never learned that? That you go over 1 because they're 1 away in the table? That's fine. I have another way that I can show you in a minute. Sound good? If you learned it this way, I'm totally fine with you doing the vertical ones this way, okay? Yes, no?
Yeah.
What, do you want me to show you the other way now or in a minute? In a minute. Thank you for being honest. People at home, are y'all okay with number 1?
Yes.
Okay, let's look at number 2. I'm hoping we'll have more participation on this one. Parent function, go. What is it? There we, oh, Drake is with me now. Okay, Drake, I've been missing you. All right, what's next? What kind of transformations do we have? Okay, oh, not up 7. There we go. Right 7, and then I heard somebody just say up 6. People at home, you can chime in if you want. What else we got? Good. Vertical stretch by 3, and that's it, isn't it? Okay. So we feel comfortable with that part. If you feel comfortable with that, graphing really should not be bad. It goes right 7, up 6, right? Where does the parent function start? 0, 0. So if I go right 7, up 6 from that, where is my new initial point? 7, 6. Love it. So over 7. Make sure I count right. Up 1, 2, 3, 4, 5, 6. Right here. I'm hoping we were at least able to do that part last night.
Yeah, I think I got it.
Okay, that's okay. Okay. All right. Before we start doing the next part, I need you guys to see how far away our x's are. Who remembers what the parent table for a square root function was? Good. I don't even care about the y's right now. How far away are the first 2? 1. So that means I go over 1. And what was our A value, y'all? So how many am I going to go up? 1, 2, 3. Are we okay with that? Okay. Check your second distance. How far away are 0 and 4? 0 and 4. So this is the tricky part about a square root function. This is the one my kids always miss on the test. I'm telling you a square root function is tricky. So where do you think you'll see it? Great. Okay. This is your initial point. It's different from the cubic and the quadratic and the absolute because their initial point is in the middle, right? So everything else is always just going to be 1 away. This one's tricky. The first one is 1 away, but that last one is how many away? 4. So watch this, y'all. We're going to go 4 away from the initial. 1, 2, 3, 4. Are we okay with that? Okay. Go up 3 to where your second point was. Oh, you can't see. Thank you. You gotta tell me that kind of stuff. Thank you, ma'am. Go up 3 to where your second one was, and then guess what? You're gonna go up 3 more because it's the next point. So up 1, 2, and it does run off, but that's okay. It's right here. So if you're saying what, that tells me you probably need to do square root functions the second way that I'm gonna show you. Okay? That's okay. You do not have to do it this way. When I was in school, I did not do it that way because I didn't like just thinking of stuff in my head. I wanted to make sure I was right. So I went over 1, up 3. The next one goes over 4. It's not just going to go up 3 because that's where your other point was. So find that point, go up 3 more. There's your third one. Because it goes up 3 each time because the A value is 3. Do you agree the Y's are 2 away, Chris? Why are you confused? This is our parent table for a square root function, right? Didn't I tell you you need to know those tables? Aren't the Y values 2 away? Because the square root of 4 is 2, right? Okay, normally for this third point, we would go up 2. What is your A value? 3 times that. So what's 3 times 2? So you can go up 6 from when you go over 4. If you don't like that, I will show you another way. That's fine. I'm going to show you another way in the notes today, actually. Sound good? Is everybody okay? All right. Y'all look so depressed today. People at home, are we okay?
Yes.
Okay. I was about to say, y'all depressed too? Dang. Y'all are killing me. I know, but there's nothing that makes a teacher want to pour her heart out and teach quite like children ignoring their questions. Gotta love it. You can't see my sarcasm. Okay, you did. Good. All right. For these, if you got an 85 or 70, it's because you did not read the instructions. It said, given the graph, state the transformations and write the equation. Okay? So, what kind of function is this? Cubic. It'll help you out if you know that. It is cubic. I'm just going to write that so I know it. Okay? Now, I know the graphs were hard to see. It's hard for me to get like really good pictures of graphs with these copiers because they're old and janky. Okay? I did my best. On your test, you will be able to see the graphs really well. All right? So, where is my middle initial point on this graph? Okay. Oswald's saying it's in the middle.
Yeah.
Do y'all agree with me and Oswald? Yeah. Okay, if you follow this over, it's in between 0 and -2, which means it's at what?
-1.
There we go. Oh, good. -1. And then if you follow it up, it's in between 2 and 4. So it's at
3.
Where's the initial point supposed to be for a parent function?
0, 0.
0, 0. This one is at 3, -1. So how did we move it?
Right.
Oh, thank you. Whoo, y'all, you had me scared. Whoo, whoo, whoo. Right 3, down 1. Very good. You should have at least been able to find that for me. It's hard to see. I know. I did my best. I found the best graph I could find. Right 3, down 1. Are we okay? Because I have to make sure, Prodney, I find them that have like perfect stretches and compressions. It's very hard. You would think Google would have more. All right, so from here, the only other 2 things we have to check is for a reflection or a stretch or compression, right? Okay, was this reflected? Good, why not? It would be flipped. The up part would be on the left, right? And it's not, it's on the right. Good, so there's no reflection. So y'all check this out. What do we know about a cubic function? What do we know about the x's? They're 1 away. Very good. So y'all, you could have gone over 1 on your graph. I'm gonna go over to 4. And then how many does this go up? It goes up 1, 2, 3. How many does it go up? 4, which means I stretched it by, ding, 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 vertical stretch by 4. Now you have the transformations. So now it's just like number 3 and 4 that y'all told me were super easy. Don't write the equation from the graph, write it from the transformations you just wrote out. Okay? So what's my equation going to be? Y equals what? Good. Uh-huh. There we go. Yep. Oh my God, good job, children. Do y'all remember doing that in math too? I don't know if everybody did it. If you had me or Miss Allred, we did do it. Because we knew in pre-cal you'd have to work backwards by reading the graph. But also a lot of you had her while she was pregnant. So she might have been out. I'm not sure. Does it seem okay though? Look at the graph, find the transformations. Then don't worry about the graph anymore. Look at the transformations, write the equation. Okay? All right, this one was even harder to read. This one, me and Oswald were struggling yesterday. I was like, what number is that at? Your initial point is right here. Good, it is at -2, and then if you follow it over here, it's in between 0 and 2, which would be, there we go, good. So it's at -2, 1. This is 2 and this is 0. It's in the middle. Are y'all okay with that? Okay, where is a square root function supposed to start? Where do they all start? 0, 0. Where is this one at? -2, 1. So what did we do? Where did we shift it? There we go, Drake, good job. Left 2, up 1. And I hear other people too, good job. Now, show me with your finger, what does a square root function normally do? You can go like this, or you can like just arch it. Show me, what does it normally do? Yeah, it's like a kind of like a pirate hook, right? Okay, good. So it's supposed to go up. Where is this one going? Which means it was, oh good, vertical reflection. Y'all talking about something. Your homework was hard. Y'all got it. Vertical reflection. Now what's the only other thing I have to check? Stretch or compression, the A value. Always check for that. So I'm going to go to my graph. What do we know about the first point? I don't even care about the other one when they give me a graph. What do we know about the distance between the first 2 points of a square root function? It's 1. The distance of the first ones is 1, which means I can go over 1 and see how much we go up or down, right? All right, so let's look. I'm at -2. This is why this one was so hard to read, because they didn't give you a middle point. But the middle of those two would be like right there. There was one. When I pull up the worksheet and show you digitally, you'll be like, wow, that graph looks so nice. The copier ate it, okay? When I go over 1, how many does this go down? Be careful, this is 1 and this is 0. Try again, how many does it go down? Oh, who said that? Good job, Ann. Y'all, it goes down a half. It only goes halfway to 0. So if it goes down a half, what did I do to it? There we go. Vertical compressed by what? There we go. Good. So now can we write the equation? Okay. Talk to me. What do we got? Y equals our f of x equals. Good.
-1/2.
Good. Square root. I heard x plus 2 and then plus 1 because it goes up 1. Beautiful. Do we feel better? Yes. Okay. Look at me. Let me see your eyeballs. I'm going to add on. Do we understand that? It is okay. Tomorrow is a practice day, so we're just going to practice all the transformations tomorrow. It is now time to add on horizontals. Do we feel ready for that?
Yeah.
Okay, I'm going to give you like a 1.5, 2-minute break to check your phone and to get more peppy for me. So I need y'all peppy. This is on your test. transformations. Your test is on compositions, inverses, and transformations.
What time did this Zoom meeting start? Because I came in a bit late.
That's okay. It started at 9. Is this Kevin?
Yes.
Hi, Kevin. It started at 9. But you're fine. So we did a warm up first. I'm recording it, so you can go back and watch on Canvas later what you missed.
Okay. I'll
Okay.
do that.
But your homework looked good. You remembered this from Miss Allred's class, I think. Did